Welcome back to part 2 on composition of functions. We're going to look at example 2, which says let f of x equal x plus 2 and g of x equal the square root of x. We need to graph f plus g. Now, the way I like to do this is graph the two functions and then add the outputs together. So let's graph x plus 2. That means the y-intercept is at 2, a rise of 1, run of 1. And if I connect the dots, this is the graph of f of x equals x plus 2. It is a diagonal line with y-intercept at 2. The square root of x, 0, 0 is the first dot, 1, 1, 4, 2, 9, 3. So kind of this curve here. So if I add these two functions together, clearly I can't add them together to the left of 0 because there's no g function there. So remember, the overlap is where the two functions' domain exist. The composition can only exist 0 and to the right. So the domain of f of x is x plus 2. The domain of g of x is from 0 to infinity, and the overlap is the green region. And it's convenient that my highlighters turn my yellow and blue into green when I overlap them. So now let's go ahead and graph the sum of f and g. 0 plus 2 is 2. 1 plus 3 is 4. 6 plus 2 is 8. And that's all that's going to fit on my graph. But you can see that the sum is going to have this interesting, very vertically stretched experience. Basically, you're putting the inputs or the domain values into the function where the two functions overlap in the domain. So the domain of f of x is going to be negative infinity to infinity. However, g of x's domain will only be from 0, we can include 0, 0 to infinity. So the overlap can only be on the interval from 0 to infinity when we add the two together. So f plus g's domain is from 0 to infinity.